Good evening, everybody. So, in today's lecture, we discuss about the hydraulic gradient line and energy gradient line. The energy gradient line is also called as total energy line. So, these two lines gives us an idea how the energy changes from point to point when the flow takes place in a pipe. Similarly, how the pressure changes from point to point when the flow takes place through a pipe. So, this information is very valuable for solving many pipe flow problems. So, that particular important topic we will take up in today's class. So, we take up hydraulic gradient line, which we call it as HGL, and energy gradient line. And this energy gradient line is also called as total energy line, TEL. So first let me take up what is HGL. HGL is defined as the line joining basically the pressure head at various points along the flow through a pipe. So HGL may rise or fall in the direction of flow depending on the pressure. Pressure changes in the direction of flow. If we insert piezometers on the pipeline, the level of water indicates pressure head and line joining the levels in all piezometers is HGL. For example, I will show you how we will write also. So, what is piezometric line? Piezometric line means line joining the piezometric head at various points along the flow in the pipe. Then piezometric head means pressure head plus datum head. So it is the sum. So that means if we take an arbitrary datum and from that arbitrary datum to the piezometric level, if we see that total head is called as a piezometric head. Otherwise, if we measure above the central, like about the axis of the pipe, that is what pressure head is. So that's the difference you should understand. Then what is total energy line? Total energy line or the same thing is also called as energy gradient line. The total energy line means actually the line joining the total energy at various points in the direction of flow, in the direction of flow, in the direction of flow through pipe is called total energy line. What do you mean by total energy means? Total energy means it is the sum of pressure head, velocity head plus datum head. So that you should remember. One more point is the TEL total energy line always a falling line in the direction of flow because energy decreases in the direction of flow. As the fluid has to spend some energy to overcome the frictional resistance and flow in the pipe. That's why the total energy from point to point in the direction of flow always decreases. As the total energy decreases in the direction of flow, total energy line is always a falling line. So the conclusion is here, total energy line is always a falling line. The reason being energy decreases in the direction of flow. But whereas HGL always need not be a fall, it need not be a falling curve, falling line. It may fall or rise in the direction of flow. The reason being it depends on the pressure at a point. So it depends on the pressure head. So that is why It may rise or fall. So these two you should remember. Now to strengthen our understanding, let us take various cases and do one by one understand actually. So draw the HGL and TEL. I will take you case by case to for your understanding sake. For example, now I have a tank here. So this is the pipe, a horizontal pipe. For example, this is how it is. So now if I take it the center line of the pipe, you can see this. So this is the pipe star here. Now the water level in this tank, if you see, this is the water level in this tank. For example, this you take it, for example, some H, no issues. How the the basically the HGL will be? What I told to you, you insert piezometers at regular intervals. At regular intervals, put piezometers. I have kept piezometers. So when I kept piezometers at regular interval, now I have seen how the water levels here are. Here this is the level, here this is the level, here this is the level. Like that it is falling. So now if I join this, so this is finally the center of the pipe. So if I join this actually like this, then we call it as this line is called the hydraulic gradient line. So how the piezometric levels, if I take it and I join them, and this is what we call it as the HGL. Now you can ask me, sir, what it is the dotted line? The problem is here, if you take it, if I note it this as A, the center line of the pipe as B, and this outlet is C. What happens is the moment actually water enters into this pipe, at the starting point, at this point actually, our problem is at the starting point, what happens is the pressure basically is not clearly defined. That is why I have written this. There is a sudden drop in pressure at this point. So that is why I have basically showed, and that distribution is not known. Why? The reason is when the flow takes place through the pipe, this is how the flow line is. So that means here there is what we call it as vena contracta. Because of the formation of vena contracta, that means the jet is reduced. Because of the formation of the vena contracta, what will happen? There is basically the what you call it as the sudden change in velocity, which reflects in sudden changes in pressure. Pressure drops and again it increases. So that is why at the entrance, the hydraulic gradient line is shown as a dotted line. That is the first thing that you should know. And rest of the things are whatever the piezometric piezometers show the levels, just joining those levels. Next, coming to how I do the energy gradient line. So energy gradient line, first if I take it, at the entrance, there is a loss of head. At the entrance, there is a loss of head. You know that. Again, this is a straight. So from here, again, this will be like this. And at the end, again, loss. See the how the energy gradient line is. Initially there is a loss. So this loss is loss at the entrance, loss at entrance. Then if I take it, this is again friction loss, and last this is exit loss. So this is the first thing. So first one is see this is entry loss, then loss due to friction, then exit loss. So because of that, so if you take it, the total energy, how much it is decreased, initially head loss at the entrance, then friction loss, then exit loss. All this we should take it up. So for example, if I take it, this, if I call it as DE, DE is the DE is the head loss at the entry. And what is then basically, if I take it from DE to then this block, if I call it as any, you can notify anything here, D, E, F, you take it, G, you take it. So FG is basically head loss due to friction. Then last one actually GC is equal to, it is head loss at the exit. So the total energy lost is equal to, this is the total energy lost, right? This is the first thing. So when you are doing it, now you know it, this is 0.5 V squared by 2G. This is equal to FLV squared by 2GD, and this is equal to V squared by 2G. These are the three things. So now this is how this finally conclusion is, this is what we call it as HGL, and this is energy gradient line or TEL. And if you see it, what is this actually? This indicates velocity head. And what this indicates, this is the pressure head. Right? If you take any horizontal datum basically, then this takes you datum head. So this is how the total energy is. As it is horizontal, the datum is common at every place. So that's why it is only pressure head plus total energy. So anywhere you say it, it is V square by 2G. That's why these two lines are parallel to each other at a particular point. And again, that by how much the energy line is above the HGL is by V square by 2G. Please always remember the, this is fundamental thing. TEL is always above HGL. How much is the, by how much distance it is velocity head. By how much distance it is above, by velocity head. So now if you see, this is the way how we do it, right? Now I will take it another case also for your understanding sake. Suppose case 2, I will take it. So now again this is the tank, right? Here we have a pipe, and now the pipe has enlarged suddenly, and it is open to atmosphere. So now if I take the center line of the pipe, this is the pipe basically. So this is the first pipe, this is the second pipe. The water level, if I take it, this is the water level in the tank. So this is the thing. So how I will do the first thing? So now if you want, basically if I take it, this should be same. So from here, basically this is going to reduce up to here basically. right? Here, what will happen, for example, due to sudden enlargement, the velocity is decreased. Because if you take the velocity here is v1, here it is v2, as the pipe has enlarged, so that means the velocity has decreased. When the velocity is decreased, automatically pressure has to increase, because according to the Bernoulli's equation, if you take it, if one goes down, the other must go up. So the same discharge is flowing through this pipe. So here the velocity some x value. But as the pipe size is increasing, the area of cross section is increasing. Naturally, as the discharge remains constant, the velocity must decrease. When the velocity decreases, what happens to the pressure? Pressure should increase. So what will happen here? There is an increase in pressure, and then after increasing the pressure, then next actually again drop to the center here. This is the how it goes. So this is how the HGL. Kindly see that HGL is not always a falling line. It may rise or it may fall. Now it is falling, but it is rising at the enlargement because of what you call it as the pressure increase. Now if I go to the second one, for example, for this first one is what will happen here, there is a loss, and from here what will happen here, again there is a loss, friction loss. Here what will happen again, there is a loss due to sudden enlargement, and then again finally what will happen actually, this again decrease, again at the end what will happen, this. So now you see how it is. For example, what is this loss actually? This loss is a head loss at entry, right? From here to here, what is this loss? Head loss due to friction in first pipe. Here, what is this loss? This loss is head loss due to sudden expansion. Again, here, if you take it, what is this loss? Again, head loss due to friction in second pipe. What is the end actually? Head loss at exit. You see how many losses actually? Head loss at the entry one, head loss due to friction in the second pipe, head loss due to sudden expansion at the basically the junction of the three pipes, right? From there, actually, this is again fourth one, and this is fifth. So, how many losses? First one, if you take it, entrance loss, head loss due to friction in first pipe, then head loss due to sudden expansion, then head loss due to friction in second pipe, and last one is head loss at exit. So all these losses. So now if I write, this is the HGL and this one is TEL. HGL may rise or fall in the direction of flow, whereas TEL is always a falling line. Now I take you into the third case. Suppose there is a tank and this is the pipe. And again it is connected to another tank. Another tank, you call it as another reservoir, you call it as whatever. So this is the axis of the pipe, right? Now what I will do, how to write the, for example, the water level in this tank is here. The water level in this tank is here, right? That shows that water flows from A to B. This is the first thing. Then how to write the best thing. So now if I take it at the entrance, I don't know. So then basically if I take it, the hydraulic gradient line means water level, because the pressure at this point is this much actually. So similarly the pressure at this point is this much. But here at the basically entrance, there is a sudden drop in pressure. That's why I have shown by a dotted line. Otherwise here the water level, this is the pressure head at this point, and this is the pressure head at A actually. Now pressure is now, as the flow is taking place, pressure is decreasing. That is the first thing. Then second, how to write the energy gradient line. Energy gradient line, if you take it, energy gradient line, if I take it initially, this is what we call it as entry loss. Then naturally here loss, and at the end the exit loss. So this part is called as entry loss. This part is basically friction loss, head loss due to friction, and this is exit loss. So if the difference between the water levels, if I take it, for example, if the difference he has given it as between A and B, the difference in water levels is equal to some H, right? This H is equal to, now you see, entry loss, that is zero point 0.5 V squared by 2G, plus the friction loss FLV squared by 2GD, plus exit loss V squared by 2G. This is how we calculate, right? All the things. So now this is the HGL and this is the EGL. So EGL, how it is? Entry loss, friction loss, exit loss. So this portion is entry loss and this portion is friction loss. This is exit loss. All three put together, the difference of water levels between the two. This is the H value. That's what I have mentioned. The same thing, even if it is inclined also, you can do it actually. So these are the some of the things. But for your case, actually, I will give you basically one in any number of problems like this. You can do basically to draw the hydraulic gradient line or total energy line. So that is kindly practice how the total energy line and energy gradient line can be drawn in the case of any of these problems. Suppose even instead of this, even different pipelines are connected. Even then, in that case, also you can really draw the HGL and TEL. But mere drawing HGL and TEL, what is the use? Naturally, we have to you derive something out of it. That we will take up in the next class. Actually, with this, I will thank you very much, and we will meet in the next lecture.
Like, share, and subscribe. Hit the bell icon for more updates.